Hey, Michael. So this is Miss Tracy. So in finding the area of a composite figure, that just means it's not a single polygon, right? There's two ways that you can do something that does not have a curve. It does not have a circle in it. And the one way is to break it into different shapes so that you can find the two areas that you can calculate and add them together. So if I did that for this shape, this is the first problem you had, and these are in meters. I would find the dimensions of this bottom rectangle. Let's call the top one A and the bottom one B. The dimensions for the bottom one is easy to find because we know that this is 6 tall by 11 wide. So you have a 6 by 11 meter rectangle. So for B, I would say that that is 6 meters times 11 meters. So that would be 66 meters, and meters is used twice, so we have the exponent of 2. And this 2 indicates that it is an area. Okay? All right, so for A, I've got to figure out, I see that it's 5 tall, but I've got to figure out what the width is. It doesn't tell me what the width is, but I do know from here all the way over to here, that's 11, because it's the same thing down here. From here all the way over to here is 11. This tells me that from here to here is 5. So if the whole thing from one side to the other is 11, and this is 5, then this must be 6, because 6 plus 5 make 11, which is the total width, right? So that means that A is 6 times 5, or 6 by 5, 6 wide and 5 tall. So A would be 6 meters times 5 meters, which would be 30 meters squared, because meters is used twice. Meters times meters, we treat it like we do a variable, and we say m to the 1 times m to the 1, we add the exponents together. So that's why we get the exponent of 2, which is what tells us that this is area. And then we would just add these together, 6 and then 9, and we bring the unit of measure down, 96 meters squared. That's one way to do it. There's another way to do it. Let me pull that picture back up. So the other way to do that is through subtraction. So I could really easily say, okay, let's pretend the whole thing is there, right? So I have 11 this way, and if I have 6 here and 5 here, then I have 11 this way. So the whole thing is a square, 11 meters by 11 meters, which would be 121 meters square, right? So that's the whole thing. But this one little section right here has been cut off, and it tells me it's 5 by 5. So I could say minus 5 meters by 5 meters, which would be 25 meters square, a negative 25 meters square, because we're subtracting the whole thing, which would still give me 96 meters square, because 11 minus 5 is 6, which would make this 11 minus 2 is 9. So either way that you do it, either by looking at the whole thing and subtracting the part that's taken away, or by breaking it into two shapes and adding them together. That's the addition method or the subtraction method. Either way, you're going to get the same number if you look at your dimensions correctly, if you take the time to find relative dimensions or corresponding dimensions. Use your corners, line them up, and say, okay, This is the total length. Find the longest length and compare it to its parallel side. Parallel sides, meaning sides that are opposite one another, are going to be equal in most of these shapes. Very rarely will you have a shape that's not equal, and if you do, it's going to be because there's something like a triangle on the end of it, which would mean drawing a dotted line to find where it's equal. And the difference between the top and the bottom would be the width or the base of the triangle, right? I'm trying not to confuse you. I don't want to do this little thing on the side. Let me see if I can find one with a triangle. Let's look at the next problem just to kind of help you get that a little bit better. Okay, so this is not the next problem. It is the third problem. So in this one, we have a triangle. And that triangle, you know, your gut might tell you, oh, we need to draw the line this way. I will say never, ever, ever draw an angle. Never, ever, ever draw an angle, because if you draw an angle, you don't know if your angle is right or not. And an angle doesn't tell you exactly where it stops. Instead, the only thing that you want to draw, the only way you want to bisect or cut up a shape is with vertical lines or horizontal lines. You never want to draw any kind of an angled line, ever. So, in order to break this up with either horizontal or vertical, we have to go this way and cut this triangle off across the top. This is the hardest part of doing the area of the composite shapes, is to figure out the best way for you to cut up the shape. That is the hardest thing to do. Now that we've figured out exactly where we need to put that line, it's a lot easier to see that this is 6. This rectangle is 34 by 6, right? Because we've got 34 across the bottom and then 6 tall. And that's the whole rectangle. We've already got the dimensions given to us. We don't have to figure that out. And we've got a triangle, and we know how to calculate a triangle. We just need to figure out what the dimensions are. So here's the thing that I see. Because this side of the rectangle is parallel to this side of the rectangle, this is 34 also. So if this from here to here is 34, and 16 of this is not in the triangle, then the other part, which is 18, is the base of the triangle. So the base of the triangle stops at the 18 right here. And then you've got another 16 of the rectangle base, or the rectangle width, that isn't included in the triangle. Now we have to figure out the height, because the height is not 20. 20 goes from here all the way to here. We know that from here to here is 6. So if the whole thing is 20, this has to be 14, because 6 plus 14 is equal to 20. And that's the dimension from the top of the triangle to the bottom of the rectangle. So it makes sense, right? We can see where the 14 comes from. But now we have something that we can calculate. So to do the triangle, we would say 14 times 18 divided by 2. Actually, let me rewrite that, because I need to put the unit of measure in there. 14, these are inches, so you put the period, times 18 inches divided by 2. And that is going to be the calculation for the area of this triangle. And for that, I would get my calculator. 14 times 18 equals, divided by 2, 126, and that's inches in area, or inches squared. The rectangle is easier, because it's just going to be 34 inches by 6 inches. So we just do that calculation, 34 times 6, which is 204 inches square. So then we just add these together, and that would be 330 inches square. Not so hard, right? Not when you think about it, not when you can break it down into the shapes. This one is really difficult to do with the subtraction method. It's a lot easier to do with the addition method by adding the two shapes that you know how to calculate together. You could do it, but it would be a lot more steps. So it's really all about being able to look at the shape and analyze, how do I need to calculate this? Does this need to be addition, or does this need to be subtraction, or is either a viable option? Sometimes subtraction is easier. Sometimes addition is easier. Sometimes it doesn't matter which way you go, they're both about the same. But you've got to be able to look at that shape and cut it into some, recognizable polygon so that you can put them together or pull them apart as you need to. Like up here with this shape, it didn't matter whether you did addition or subtraction. It was 2 steps either way, right? With this one, if you were to do subtraction, you would have to draw the whole thing out. Actually, let me undo that. You can do it with subtraction, but it's a whole lot more steps. I'm going to pull this aside up here and show you that you can do it with subtraction also, but it's a lot more steps. So you would have to envision, okay, I've got this one big rectangle and it's 34 by 20. All right, so the big rectangle, 34 by 20, 34 inches by 20 inches. That would be equal to 680 inches, right? So 680 inches squared, because 34 times 2 is 68, times 10 is 680. So that is the whole thing. Well, now though, you have a trapezoid right here. And you would have to figure out, okay, I've got 6 here, so that makes this 14. And then the base is 34 on one side and 16 on the other side. So that means you've got a trapezoid that you're subtracting. And then you'd have to know how to do the calculation for a trapezoid, which would be base 1, 16 inches, plus base 2, 34 inches, times the height, which is 14 inches, divided by 2. And that would be minus, because this is separate, right? -1. So you would have to do all of that. 16 plus 34 times 14 divided by 2. So minus 350. 680 minus 350 is 330 inches square. So same answer through addition or subtraction, but which one is faster? Which one works for you? Which one helps you see it the best? Do it the way that you see it, because that's the way your brain works. Don't try to force it, right? Don't put a round peg into a square hole, or vice versa, right? If you see the shapes broken apart, do the addition method. If you see the void, do the subtraction method. It's up to you how you want to do it. And it will work if you can get the dimensions to do it, right? If you can see the dimensions to do it. What you've got to do is practice looking at polygons, looking at these shapes, and finding their base shapes. How can I break this apart? What makes sense to me? What do I see? Look at the world around you. Look at, boxes and take them apart. Look at your furniture and see the basic shapes and parts of your furniture. That's going to be what helps you do well with geometry, is seeing those shapes in everyday life so that you can pull them apart when we have these composites. It's a special gift, and when all else fails, you tell Kyla, hey, I need your help. Get over here. How do I break this apart? I can't find it. Because she's very good at that. She's good at math. We know that. So let me see if there's another one I can help you with on that assignment. Okay, so this is the hardest one I saw. And I thought, yeah, he might need help with that. So this one, you're going to break it into as many shapes as you need to break it into. There's a lot of shapes going on. And I would highly recommend the addition method here, where you break it into shapes and add it back together, because otherwise it's going to be real confusing. So the first shape that I see here is this rectangle. I mean, that's a no-brainer. It's 4 wide from here to here. That's its total width. And its total height from here to here is 25. So we know that. We'll call this A. A is a rectangle, and it is going to be 4 meters by 25 meters. And for me, one of the things that helps, and it might help you, is to outline the shape. When you figure out what the shape is, outline it so that you can see that shape. Notice again, I'm not drawing any angles. Everything is either perfectly straight up and down and vertical or perfectly horizontal, because the only thing that I know for certain is that a 90-degree angle stops and starts in the same place in the top and the bottom. So an angle means I can't do the math correctly. I don't know where it's cutting something off. So you want to only have vertical and horizontal lines. So if this is A, I see that another natural ending is right here at this corner. So this is another rectangle right there. And that's going to be rectangle B. We'll call him B. Now, I don't know yet what B's height is, but I do know that he's 10 wide, so 10 meters by something. But now this is where I can do my comparison. The thing that I can relate it to is this line. I've got a connecting line from here all the way up to here. And I know that when I look at this parallel line over here, that this line is going to be the same height as this line. So they're 25 and 25. But this number right here tells me that this rectangle doesn't start until after 21 meters has passed. So if this line is the same length as this line, 25, but this shape doesn't start until after 21 meters, I can take 21 meters from 25 meters. The difference is 4 meters. So 21 and 4 is 25, which is the total length of this line, because it's the total length of this line. So that tells me that triangle or rectangle B is 10 by 4. So 4 meters goes here. Now I've got this weird wonky shape. You can do two things with this shape. You can either treat it like a trapezoid, or you can treat it like a rectangle and a triangle. So if we treat it like a trapezoid, then it's a little bit more complicated, but it's only one calculation. If we treat it like a rectangle and a triangle, it's 2 calculations, but it's a little bit easier. So let's do the rectangle and triangle. That'll make life a little bit easier. So this is going to be C, and I can already tell that C is 10 meters wide. So rectangle C, because rectangles are easy, right? So 10 meters, we don't have to do any kind of fancy calculations with those. But I don't know the height of C. Okay, I do know that this line right here is this height plus this height. And if it's 4 meters over here, it's 4 meters right here. So if this is 4 meters plus 8 meters, this has to be 12 meters tall. So C is 10 meters by 12 meters. So now I just have to figure out my triangle, and I know one of the dimensions of my triangle. We'll call this D. D is a triangle. 12 meters here means we have 12 meters here, right? So this is 12 meters tall. So 12 meters times some other, the base, we're going to divide that by 2, because that's how you do a triangle. I need to figure out what this dimension is, though. The only thing I have as a reference is this entire width all the way across is 30 meters. Well, I know that this is 4 meters because this is 4 meters. And I know that this is 10 meters because this is 10 meters. And I know that this is 10 meters because this is 10 meters. And it's a rectangle, right? So it's the same. Parallel lines are the same length. So if I add these up, I get 10 plus 10 is 20, plus 4 is 24, right? So this is 24, so this has to be 6 meters, because 24 plus 6 is 30, and 30 is the length from this end to this end. So there's my other dimension for this triangle. So times 6 meters. Now I just do the calculation. 12 times 6, that's going to be 72, divided by 2, that's going to be 36 meters square. This one is 120 meters square. This one is 40 meters square. And this one is 100 meters square. Now all I have to do is add them all up. Bring down my meters square because they're all like units, they're like terms. This would be 6. This would be 6, 7, 8, 9. And this would be 2. So 296 meters square. And we use the addition method. So you see there's a process of comparison. You're comparing your sides. Parallel sides are going to be relative to one another. You can add and subtract parallel sides to find missing dimensions. Just like we did across the bottom here, where we know the whole thing was 30, but we had to find the parts that were in the other shapes before we found what was left over for the base of our triangle. So those are the things that you need to do. And like I said, whenever you draw that shape out, it makes it easier to do the calculation. It makes it easier to see what's left over. So don't be afraid to sketch it out, to mark it up. That's what you want to do. That will help you a lot. And holler for Kyla. Do that too, and that'll help a little bit. All right. I hope this helps you with the composite shapes. I'm going to look at the rest of the lesson and see if there was something else added in. Okay, now we get to the hard part. And it's not really super hard. It's just there's another step that you have to take to find the area. And that's when we have these half circles in here. So I like to get the easy part out of the way, and I'm just going to take this rectangle and go ahead and separate it. So this rectangle, we'll call him A. We've got to find his dimensions, right? So if this is a circle or a half circle, then that makes this a radius, and that makes this the center. So then this is a radius, so that means it's the same measure, and this is a radius, which means it's the same measure. So now I have the width of my rectangle is 4 plus 4 plus 6, which is going to be 14. So A is going to be 14, and I didn't see what the unit of measure was. Hold on. Okay, so I apologize. I just realized I did not press the record button when I came back from checking the unit of measure. The unit of measure was feet. So what I did, we found the rectangle. We found that it was 14 feet by 10 feet because this is a radius, this is the radius here, this is a radius, and this is a radius. So that's 14 across the top. And if this is the radius of 5, we have 5 and we have 5 here. 5 plus 5 is 10. So 14 by 10. B is this half circle. So we did pi r squared, the radius squared. So pi times 4 times 4. And it's only a half of a circle, so we divide it by 2, which gives us 25.12 feet squared. And in this half circle, we called him C. He has a radius of 5. So we did the same thing. We said pi times 5 times 5, because radius squared, right? But it's a half of a circle, so we divided it by 2. And that gave us 39.25 feet squared. When we added all of that together, it gave us 204.37 feet squared, and our directions were to round it to the nearest whole number. So 204 feet squared would have been the answer here. So don't let these confuse you. Draw the shape out to see what you need to figure out. Only draw horizontal and vertical lines unless you have a circle, and then you can't help it. You know, we're not going to actually be cutting them off cutting them up into shapes anyway. Our circles, we treat them as a whole, and then when we have a half or we have a quarter, if we have a half, we divide it by 2. If we have a quarter, we divide it by 4. If we, depending on the fraction of the circle, that's what we divide by, right? So I think that's all that we did in that lesson, and that's all that we need to look at. If you have any more problems with trying to figure those out, let me know. Just message me and let me know if you're still unsure about how to do those things. Also, say, hey, Kyla, what's up? I don't know how to do these. This is hard, because it is hard. But you can do the hard stuff. I have faith in you. You're a smart young man. And I'll be here if you need any more help. And also, we are meeting at Coffee Central on Mondays. What used to be Coffee Central. It's the Baker's Corner. It's that little coffee shop right in front of the church, right in front of Fernando Baptist. We're shifting our time from 2 to 5 because they've changed their times, and now we're going to go from 1 to 4. So we still have 3 hours. You can drop in as you need to, and stay for however long you need. And there's just not that many of us, so it just didn't make sense to get the whole church for just like 3 or 4 kids. So just show up, get a cup of coffee, or if your mom lets you have it. Or they have water. They have a water station where you get a free cup of water, so mama doesn't have to send you any money. But also mama might have a good time in another room, hanging out, taking a break. So we're going to do that. We started doing that this week. You're welcome to join us, and we'll see you when you see you. Keep asking questions. I know you can do this, and I will see you next time. Bye for now.